Okay, guys, welcome back from the break. So we'll start off with the third quadrant of today's radar, which is languages and frameworks. And the first blip that we want to talk about in this is Micronaut. Micronaut is a Java-based framework for building server-side applications. Now you would think, why do I need another Java framework? I already have enough of them. I already have Spring, I already have Microprofile, there used to be Drop Wizard. Uh, do I really need one more? So Micronaut is slightly different though, in that its focus is on raw speed and memory consumption. It's optimizing for speed, low memory, low footprint, zero dependencies, that sort of thing. And essentially their approach is this. They basically said, you know what, why does it take so much time to start up a Spring Boot app? Or why does it take so much time to start up, let's say, Drop Wizard or Microprofile? And why do these frameworks consume so much memory? And in the end, the answers boils down to this. It's because all these frameworks, which do a lot of magic, you guys probably have used Spring and you notice you put a few annotations and things just magically happen, right? There's a lot of magic happening. And how does it happen? It's all via reflection. There's a lot of work happening during startup where Spring or whatever framework is scanning through your entire code base, identifying all your objects, gathering all the metadata, caching it, processing it, and then figuring out what to do. So there's a lot of work happening on bootstrapping of those frameworks. And if you want to optimize for speed, and this is what they wanted to do, then obviously this is going to be a problem. So they said, I'm not going to use runtime reflection. But then you still want all the goodness of Spring. Spring was, despite all the bad press of Spring in the olden days, modern Spring Boot is actually quite usable. Things just work, right? You want all that goodness as well. How do you do dependency injection then? Do you want to go back to the old days of, XML-based config and stuff like that? You don't want that. So how do you do it? And what they basically did was they basically said, okay, I'm going to do dependency injection and do all that Spring does, but I'm going to do it at compile time, not at runtime. And they basically use Java's annotation processing and ways of adding plugins to the compilation process to essentially do what Spring does, but at compile time. They even claim to be essentially a compile time DI mechanism. That's the core way in which they do this. So based on all this, they've ended up with sub-second startup time. And what they are now doing is taking it to the next step with GraalVM. How many of you have heard of GraalVM? Yeah? So GraalVM is Oracle's universal virtual machine. Essentially, it's a virtual machine they've built where almost multiple languages can run on it. And apart from that, they also have one more aspect of GraalVM, which is to compile your, your intermediate code, your byte code, into the native machine code. So if you use GraalVM and compile your Micronaut apps to native code, they've managed to get your startup time down to a few tens of milliseconds. And for Java app, that is quite unbelievable. Literally you start it up and it runs. Now, why is this interesting? Because now it opens up Java to a range of applications which you couldn't use it before. Things like IoT, where resources are a constraint. Places like Lambda, for example, sometimes the cold startup problem of Lambda is just too much for Java. It may take too long for you to seriously consider it. But with Micronaut, that might actually be an area you can seriously consider. So apart from all this, they do have some other interesting things. The thing is they want zero dependencies. But if you're in a microservices environment, you need a lot of capabilities. You need to be able to do all these circuit breaking and retries and all those sort of things which every microservices setup needs, right? Unless you use service meshes, in which case you don't need it. But you might still need some of it. You can't do entirely everything out of process. You need to be in the context sometimes. And they do a lot of this. They make it a core part of the framework itself. So that's Micronaut.
Okay, so the next blip that I'm going to be talking about is Aaron. So we heard someone using RabbitMQ, a few people heard of or used Kafka. So Aaron is yet another message PubSub peer-to-peer infrastructure. But Aaron is different, right? In the sense, if you want something really low latency, right? When I say low latency, you're talking about hundreds and thousands or literally 100,000 messages a second or even higher. A lot of queues don't scale. I mean, of course, you can do this in Kafka, but you need like a data center for this, right? Sometimes you don't need, 100% exactly one semantics in a message, right? A lot of people, I think, so this is what NoSQL was saying in the database world, right? Not every transaction is as a transaction, right? This is what the database providers actually, impose the constraint that everything has to be ACID. If you actually think, it need not be, right? Similar fashion in the messaging world, you don't need 100% guarantee for every single message. Sometimes you just need to exchange and you need a lighter framework for this. So if you have a use case, something like this, as opposed to something heavyweight like a RabbitMQ or a Kafka, Aaron is a very good candidate for that. So if you have come across Martin Thompson, so he's extremely popular in the high performance computing space. So Aaron, there are two implementations. There is one in Java, one in C++. Both are equally performant, C++ slightly higher. But you can have a Java version that is equally performant and you can use this. But this is not like your Kafka, right? So initially it started on top of UDP because they felt TCP is too much overhead. So this is the level you're talking, right? For you to have TCP as an overhead, means you're doing a very serious low latency stuff. So if you are in that space, for example, a lot of domains are in this space. If you're doing ad tech or you're doing trading, anything in finance will come under this, right? Traditionally in these spaces, people go for something extremely niche and proprietary, which costs millions of dollars. Luckily, Martin Thompson, the project he did, the client sponsored the work and made it open source. So this is 100% open source. So the whole community can benefit. So if you have such an interesting use case, do give a try to Aaron.
Oh, right.
Tycho is here, right?
Yeah, it's there.
Okay, cool. 97. How many people are using Selenium? Or heard of Selenium? Okay. So I think not a lot of people know this. ThoughtWorks actually wrote Selenium, as in at least ThoughtWorkers wrote Selenium, and people left and all that. So it is safe to say that the Selenium as a project originated from ThoughtWorks. So there is a team in ThoughtWorks called Gauge who write testing tools. They actually did something very innovative, right? So they were looking for what should be the next big thing to disrupt the testing landscape. And they saw that how we write tests for the browser for a long time, and even though you have hundreds of tools, the fundamental driver has been Selenium, right? It kind of dominated the market. But if you actually see, the challenge that the team was taking is, can you do something better? Can this be faster? If you're given a choice to redo this again, what would you do, right? And then the Chromium dev tools, SDK came along, and they were thinking, okay, can we leverage this and bypass a few layers and directly automate a browser using its own SDK, right? Rather than going through multiple levels that Selenium driver has to go through. Because at that time, the browsers were not exposing API for automation, right? That was not browser's intent. But now, with the Chrome dev tools becoming a standard, so Firefox is now adopting, IE is also going to be adopting, I believe. So this is now slowly becoming a standard, but the Gauge team took a bet some time back, and they actually wrote a driver using the Chrome DevTool SDK. So what does it do? So if you ever suffered from tests that are very flaky for UI because you need to wait, or you have a complex XPath selector, or you really wanted to say the button that is close to this UI, but you can't say, you need to exactly select it. A lot of those features are now with Tycho, right? And DevTools being universally adopted, even though it is predominantly Chromium based, you are beginning to make this a cross-browser thing. Right? So it is written by ThoughtWorks. I think when we open sourced, in like a few weeks, it got like 1,000 stars in GitHub. It was trending Node.js project for a week or something like that. So a lot of people liked it. Good community feedback. So if you want to just give a try, many projects inside ThoughtWorks is now starting to use Tycho. Not because we are saying it's our project. People just love it and they pick it up and use it. So do give a try. You can use Tycho as an independent driver, or you can also use it with Gauge, which is also open source. Cool, that's what we had on languages and framework.
Yeah, let's talk about tools. And this is the last quadrant for today. So let's start with Traefik. Traefik is a reverse proxy like Nginx. I'm guessing most of you are familiar with Nginx. So what distinguishes Traefik from, why Traefik instead of just Nginx? I guess the first thing is Traefik is a lot more native to the container ecosystem world. We talked about service meshes and all those sort of things which are native to the container ecosystem world, right? Like one of the things about reverse proxies is it needs to know all its upstreams. And gone are the days of static upstreams where you exactly have two nodes which are in an active mode. It doesn't work like that anymore. You basically have a very dynamic upstream where things are going up and down, and sometimes it's in this IP address, sometimes it's in that IP address, sometimes there are 4, sometimes there are 5, so on and so forth. And Nginx natively can't handle it, so you have to have additional templating and stuff to make that work. Like for example, if you use console as a service discovery mechanism, you need console templating or some other process which talks to console, figures out where are all the services and changes Nginx's config and restart Nginx. Now that's complexity, additional complexity. Someone has to sit and monitor and update, and you have to restart it. And in very dynamic environments, it's a pain in the ass because when you're restarting it, there is a brief downtime as well. So Traefik is more natively aware of these concepts. It has a dynamic backend capability where it's integrated to various orchestration systems like Kubernetes or Consul and quite a Docker Swarm, a few of them, and it can dynamically sort of update its backend. You can change its configuration without a restart. It's like a restart less config update mechanism, and it also embraces some of the concepts of these sort of setups. It has very tight integration with Let's Encrypt. Have you guys heard of Let's Encrypt? Yeah, it's a way to get HTTPS certificates, and it's a very nicely automated mechanism, right? And Traefik has brilliant integration where you literally just have to provide 2 or 3 pieces of information, and it can automatically get that upgraded for you as well. So apart from all that, it's a really simple Golang binary, so it's very easy to install. For all these reasons, it's probably one of those entrants in the reverse proxy setup, which is very attractive, particularly if you're in this ecosystem.
Okay, so this is going to be again about Kubernetes. Have people heard of Kubernetes operator? Do people use Kube? Okay, not a lot of people use Kube, so let me introduce the blip. What a lot of people do not realize is Kubernetes is not a platform, right? It is a platform to build a platform, right? It is extremely low level. People don't realize that. Um, in fact, this is one of the kind of a keynote session of the latest KubeConf, that people don't realize that you can't directly build a lot of things just out of the box on the mainstream open source cube. It's too raw and it's too complex. So what has happened is, like things mature, right? When Git came out, it was too raw, and then it matured and matured. Like any software project, the ecosystem is now maturing, and what people have realized, you need a way and a convention to package, to deploy, and also to maintain, right? And this applies to Cube as well. So what people from CoreOS has done is, I believe this is from CoreOS. So they defined a standard, right? So Cube always had something like what they call CRDs. So if you have a custom resource descriptor, you can think of a way to describe. So if I want to install CockroachDB, for example, in Kubernetes, what people do is they package CockroachDB as a kube operator, so that once you install that operator, you will have standard namespace, standard way to start, stop, package, and deploy, right? So pretty much libraries and platforms that is getting deployed in Cube, they package in a way of a Cube operator, right? So this is now becoming slowly the standard in which you deploy, right? And you have to deploy in such a way that there is no namespace collision, you don't disrupt, and it is easy to just have a different namespace and address things, as opposed to there's just one global namespace, right? So that is one advantage. And obviously, so all three phases, you will have an ability to package, deploy, and maintain if you just adopt the framework of the Cube operator. Right? That's Cube operator. One more?
Cool. So the next one we want to talk about is Batect. Batect is another actually ThoughtWorks open source project, an ex-ThoughtWorks, I think. I don't know if he's still in ThoughtWorks. But essentially, increasingly now when people are starting to use containers in the dev workflow, right? How does that work? You probably have a container for your build. You probably have a slightly different container for your testing. You probably have a different container for your integration testing because you need to connect to a database. So you basically have various workflows for your containers. But if you're building, let's say your language is Java, you probably have Gradle as your build script. You're probably not going to add all these tasks into Gradle itself, because you want Gradle itself to be just about your code, your Java-based project. So where you're going to orchestrate all these, how do you build? You have to launch up this container and build within it. How do you test, so on and so forth. So various ways, right? Some people just do scripting. Some people create make files. Some people even use Docker Compose to do all this. But essentially, there is an orchestration problem. There is a way in which you need to be able to articulate what is your build, what is your test, how do you do your integration testing, so on and so forth, and in a way which is maintainable as time goes by as well. And that's the space which Batect tries to address. It's basically a simple YAML-based configuration where you can say, here are the containers I'm interested in. There's a build container, there's a test container, so on and so forth. And here's my build task, which says do this, but using this container, so on and so forth. So once you have your YAML description, pretty much that's all you need, because then you don't need, you can use that not only for your local building, testing, and so on and so forth, but the same thing can now be used in your CI pipeline as well. So it's, I think this sort of fits a set of tooling which is coming up. I think Cage is another one here, which is all about how do I optimize my dev workflow? How do I more natively integrate containers and my native build tooling, etc., in a way which is sort of seamless?
Cool. This is probably the last clip before we open up for questions. So this is again going to be on the topic of microservices, not especially Kubernetes, but you can also apply this to Kube. For a long time, right? Let's say if you want to impose any kind of security restriction, right? What do people do now? I want to block something, I want to allow something. What do we do now? Yeah, and what does the firewall do?
IP tables.
Yeah, IP tables, listing, don't talk to this port. 80 is blocked. Only, 443 HTTPS is allowed. Right, so basically you are in layer 3 or layer 4 of your networking stack. It's either everything is thumbs up or everything is thumbs down, right? Which is great for a period of time, right? But the moment you have hundreds of services talking, there is a need to express this at layer 7 as opposed to like at an API level, right? You do not want an account service to be called from, I don't know, anything other than this namespace of services, which is authorized to update the bank account details, right? This is like the same old design problem where if you, a switch is faulty and you press the switch, it should not take the flight down, right? It's similar to that. You need compartmentalization, and the same applies for security and auth, right? And let's say if you have to do this, it is very difficult to do this in a container orchestrator world because what is the IP that you will allow and which port would you allow? You have no clue, right? There you will have ranges of IPs, and the next second that pod will die and the pod will reappear in like another host in another data center, right? So you cannot say this IP and this port can talk to this IP and that port, right? That's not possible. Um, so until, Linux always had, or Unix even had this concept of a BPF, Berkeley Packet Filter. This is like 20, 30-year-old tech. It's been always there. But what has happened is there has been an extension that's called eBPF. It's extended BPF. What's a BPF? So if you are in the networking space and you're a network engineer and you want to analyze a few packets, you will write a pattern to analyze, and if you inject to the kernel, you have more capability. So the kernel gives you a sandboxed way for you to inject code, right? And that is for packet filtering. What people have now realized, this capability is now extended. You need not just analyze packets, you can have a lot more capability, right? So this is something Linux as an ecosystem gave to application providers. So, but it is extremely lower level, right? To modify a kernel, there is a lot of sandbox restriction of an eBPF, and it is like an assembly, right? So what Cilium, the tool, has done is it has taken this capability of Linux to have a flexible way to inject code into the kernel and exposed in a way that you can have a declarative way to express security without security and access control without IP, right? So it kind of decoupled it. So you can declare security to a pod and a service and a container without saying this IP and that port, right? This also means a lot of, you don't have to go down, let's say there are two pods running in the same host. If not for Cilium, they go all the way down from layer 7 to 0, go up, and then hit all the way layer up. Cilium kind of bypasses quite a lot of layer because 7 to 7, it can actually talk and enforce policy. It is open source. You can do it in Cube, in Docker, in Mesos. It's kind of orchestrator neutral. And it gives you this fundamental way to express security in a declarative way, right? And it is fairly new. We are evaluating this in quite a few projects without which we can't do, it's either a binary thing. Now we can have a very a fine-grained security and access control policy with Cilium. Cool.
Cool. I think we are mostly done. Before we wind up, any questions so far?
Anything that you want to ask? Any other blip that you want us to talk? I think we are like 10 minutes, 10, 15 minutes we can have. Huh.
Which one?
We have transferable something. Okay, so see, this transfer learning typically was in the visual training space. It was not there in the natural language processing space. But there has been recent research saying that you can do transfer learning in an LNP as well, right? So there are more detail in the blurb. I won't be able to do justice. But it talks about innovations in the transfer learning to apply that in your natural language processing. People used to do this in vision, and now you can do it in NLP. Sure.
Okay, sounds good. I think we are mostly done. I think the last thing for us to close the day with is that the radar as a visualization is not tied to the ThoughtWorks radar. It's open source, so you can create your own radar. And I think it can be interesting in your organizations if you feel you'll benefit from an internal organization radar for you guys to sort of say, here's upcoming technologies, here's what we want to try, here's what we have adopted, so on and so forth. So feel free to give it a shot. Yeah? Okay.
Cool. If there are no further questions, we are done.
Thank you, guys.
Thank you. No questions? Cool. Thank you.